Okay, this is part 3 of the Northern Pacific low killed, and I'm going to show some very strong proof, strong evidence and what I consider proof of the Haarp downburst off the coast of Oregon, which shut down the rain in Oregon, or before it could enter Oregon. This is the low pressure that was smashed down yesterday. This is the morning of September 25th, and we can see from the sunlight hitting cloud tops that this looks like pretty much a natural cloud formation. And what I want to focus on is this group of thunderstorms down here, because this is the group that tries to, or gets the Haarp downburst before it can bring any rain into Oregon. Okay, so if we look at the first view of this cloud group in water vapor mode, we can see it's forming up thunderstorms, and they're moving straight east with no rotation at all. And that's the important thing I want to show here, is there's no rotation, because clockwise rotation is going to mean high pressure. And if we jump ahead a couple hours, now we see, oh gosh, it started to rotate clockwise. Now why would that be? That's actually not possible if we look at the surface winds, which are here. If we look, here's the surface sea level pressure map. These winds right off the coast of Oregon are actually turning to the left, and they're going straight north. So if there's any kind of rotation here, you would expect to see counterclockwise rotation. And the jet stream is basically the same. Right off the coast of Oregon here, you would expect, if there's any rotation, it's going to be counterclockwise. But what we actually see is we see it turning clockwise. The only way this can happen is if there's high pressure. In other words, descending air on top. And basically that is what's happening. If we jump ahead a little bit, hopefully we can see the Haarp outflow boundary. It's a roll cloud of dry air, and it does show up on these satellite maps, but it's very faint. Hopefully the PC is not going to lock up, and we get to see this chart. This is not good. But what happened was, oh, I'm sorry, press the start button. Okay, now we're starting to see this Haarp outflow boundary. It's this dark circular ring, and inside the ring we see clockwise rotation. We also see the clouds getting, the thunderstorm getting smashed down. Let me go ahead and stick some color on that, thunderstorm color. Okay, it starts out as a nice strong thunderstorm right at the beginning here. Okay, we got thunderstorm forming up, and this do the downburst. It's breaking down, and then the central thunderstorm is gone. As this roll cloud proceeds outward over this unstable air, it actually pops up a new thunderstorm here, which there's a duplicate frame there. Okay, if we jump ahead, we're seeing a strong clockwise rotation now. This is strong clockwise rotation. The central storm complex has been flattened out, squashed by descending air. And so what they're doing, they're heating the ionosphere 90 miles up, supposedly, probably not that high. And that air expands like a balloon popping. It presses this air down, and descending air is always going to turn clockwise because of the Coriolis effect. So this clockwise movement inside this dark ring is proof of descending air. And as I showed you, the surface and winds aloft, there's no natural explanation for this clockwise movement other than the Haarp downburst. And the Haarp downburst also explains this expanding ring here. This is the Haarp outflow boundary. And we can actually see it expanding here. Here it is, and it's moving outward. Here it's very clear. You can actually see, oh gosh, a third of a circle there. and it actually shows up better in the subsequent maps, the long wave infrared. Okay, now here, this is just sort of water vapor color, and we can see this storm pops up and then it gets smashed down, and if we look at these clouds to the south here, they are actually moving to the west. This is totally in opposition to the surface winds and the jet stream winds. This entire thing is rotating clockwise. Meanwhile, the clouds the storms are being smashed. Okay, this is later. Let's see. Let me go ahead and jump to long wave infrared. Okay, this is towards the end as the entire storm group is moving on shore. Now here's the long wave infrared. Now this is the morning. You can see these storms, they're just moving east, there's no rotation. Jump ahead. Now we see rotation, we also see the ring form. Here's the ring. Let me stop it. Okay, here is this ring. This is the outflow boundary here. And it's actually a full circle right here. Pretty amazing. Now jump ahead in time again. And we're going to have to step through to watch this ring propagate. Here's the ring. And there's a lot of duplicate frames in here. Apparently the Photoshop guy couldn't keep up, so they've got a bunch of duplicate frames. Okay, now here is just showing the clockwise movement again. So it's not just that it's that these clouds are moving outward and stationary. They are actually moving to the west. If we look at the vertical velocity map, we do see that here it is, 30,000 feet, and what we see, I can get it in frame here, right here off the coast of Oregon, we see gray is falling air, orange is rising air. So we do see some falling air, and this is about 1 p.m. Mid-afternoon. And here at 5,000 feet we also see the same thing. Another area of sinking air off the coast of Oregon. Now if we look at the next rad, we have a lot of rain. This is actually very late in the afternoon. So a lot of rain is going ahead and moving into Washington State. I'm sure they're quite disappointed with this result, but they did keep it out of Oregon. It was stuff ahead a couple hours, more rain. Now if we look at this is Medford, Oregon, and they're not showing anything out in the Pacific. If we go to Portland, we get this. And they've been given this error message all afternoon. So these radars that are looking out into the ocean, they don't want anybody looking at them. So why are they doing this? I think it's because they want to extend this horrific California drought up into Oregon. This brown is exceptional drought. I know from a person that I talked to this morning, it hasn't rained for 6 months. It has not rained in Northern California until this morning, and it's been 105 all summer. So next you have extreme drought, then you have severe drought, then this light brown is moderate drought, and yellow is abnormally dry. They're going to try to extend this exceptional drought on up into Oregon. That's what the purpose of this Haarp downburst was today. And that will set up massive forest fires next summer that cannot be stopped. Okay, one more thing I want to say, and that is it's very difficult to see these things on the satellite and to really prove what's going on. So an easier and better approach is to, for several people on the West Coast, spend $120 on a really cheap little spectrum analyzer and hook it to an old XP laptop or Windows 7, and then find an old TV antenna that used to be on somebody's house. Those 3 things are all you need to see this Haarp radio signal. And if we have 2 people say somebody in Seattle and somebody in Northern California, you know, they can compare compass readings on their direction finding antennas, which a TV antenna will actually give you the direction of the signal. And with that simple technology, $120 investment, we can have a network on the West Coast of people looking for these Haarp downbursts, and that will be extremely effective, because then we can be aware of what's actually going on instead of having to search these doctored satellite images. And even then, you know, I can see it perfectly clear. To me, it's absolutely crystal clear proof. But once this is up on YouTube, it's very questionable if other people can see what I'm seeing. So we need to have a network of these $120 spectrum analyzers looking for these signals, and you will see this signal many times every day. Incidentally, since the Haarp transmitter was devoted down here, we can see that the main low pressure has rebuilt itself. Wow. So this is a late evening, and look at this. Low pressure has rebuilt itself very nicely, and look at all these aerosol trails up here. So they just never quit. They are relentless, and that's why we need to develop new tools for dealing with this. So if I can help anybody set up the spectrum analyzer network, that is really a top priority. Anybody in California who wants to end this drought, spend $120 on this thing, and we'll get a dozen people on the West Coast looking for the radio signal. Okay? This is just really the most helpful thing you can do right now. Let me know if I can help, and I really appreciate you watching. Thanks.